Welcome to Matematika. Today we're going to do the part 2 of problems and solutions in the rate of change in linear and quadratic function. We'll start with number 1. You are asked to complete the table for the following quadratic function. If you try to observe the input value, which is the x value, you have a negative 3 to a positive 5. Well, the output, there is a missing value of the output value in when x is negative 3, when x is 2, when x is 4, and 5. And that's the one we are going to do right now. We will look for those values and we have to complete the table. First of all, we want to determine if there is a minimum or maximum value of the quadratic function that is shown in the table. If there is, then we could use the property of symmetry to help complete the missing value. Now, what I usually do, I want to visualize how this look like when we graph. Say for example, I try to make a sketch here. Let's say you have 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, then negative 1, 2, negative 3, 4. This is negative 4, negative 3, and then I'm just looking at what value is given here. This is 5. We have a negative 1. Okay, we have a 0, 1, 2, 3, 4, and negative 2, negative 1. For the y value, 1, 2, 3, 4, 5. Okay, all right, I think that's it. I'm just making a sketch so that I could see how it looks like in a graph. So if we have a negative 2, I'll start with negative 2. The value of x is 0, so this will be our first point here. When it's negative 1, the value is negative 3. So let's say somewhere here. When it's 0 in x, it's negative 4, right here. When it's 1, it is negative 3. Okay. So 2, we don't know. When it's 3, it is 5. So we have our points right there. So actually, the points that we could plot is only 1, 2, 3, 4, 5 points. If we try to connect, of course, we come out with a parabola. Right? We know that the shape, when we connect, is the shape of a parabola. Quadratic function has a parabola as a graph. Okay. If we look at this graph, we could say this point right here is our minimum point. Okay. So our minimum here is 0, negative 4. So we could say right away that there is a minimum value that is created or that we could create in this table. All right. So we could see that the other half, the left side, is a mirror of the right side because of this point right here. We could tell. When it's negative 1, it's negative 3. When it's 1, it's negative 3. Okay? So we could find or determine right away our sum of our values. And then afterwards, we could get the first and second difference. All right. So I could say the value of f of -1 and the function when it's 1 are equal, right? They come up with both -3, okay, which is equals to -3. And then the minimum values occurs at this point right here. This is the minimum. So in other words, we could have the x value between -1 and 1. That is where we found our minimum value, which is 0, -4. Since the quadratic is symmetric, okay, I could find a symmetry. So this is symmetric about a point, so we could use this to find the other parts. It will be easier for us. So in other words, 2 positive 2 would also be equals to 0, since they are symmetric. All right. So positive 3 and -3 would also have 5. All right. So the only thing that we really have to find is when it's 4 and when it's 5. All right. So to find this missing value, we could use the first and the second difference. Okay. Let's look at this. All right. Let's do the first difference. The difference from 5 to 0, that means 0 minus 5 is -5. So the difference from 0 to -3, that means -3 minus 0, the difference is -3. Okay? So the difference from -3 to -4, that means -4 minus a -3, that is -1. The difference, -4, -3, -3 minus a -4, that's +1. Then 0 minus 3, change the sign, you have a +3. And then 0 to 5, you have a +5. 5 minus 0 is 5. So looking at this difference right here, this is the first difference. All right. Let's do the second difference. I think I'm going to do it here so that it will be clear. All right, I can have it here. So -3 minus -5, that is equals to 2. That's the difference. -1 minus -3, that is also 2. 1 minus -1, that is 2. So we can see a constant second difference. Okay. Our second difference is 2. So in other words, you expect that the difference here would be like the second difference would be 2. And what do you think would be our first difference here? It would be 7. Right? So 5 plus 7, that would be equals to 12. 5 plus 7. And we do another second difference of 2. Then we have 7 plus 2. That the first difference would be 9. Okay? So in other words, 12 12 plus 9, that would be equals to 21. All right. So our table is completed now. What I'm doing here, when I make a sketch on the graph, I want to be sure the function has a symmetry. It's the property has a property of symmetry. So we found out that it's symmetric. Okay, so by being symmetric, we were able to find the x value, the input value of when x is -3 and when x is +2, because we could see a symmetry here. By looking at the minimum value of 0 to -4, we could know the left side and the right side of that minimum value. I think that helps in getting the missing value. Let's do number 2. The table gives the values of function h for selected values of x. So we have x here, values -8, -4, and 4. And the h of x is 23, 17, and 5. The question is, if the function h is linear, okay, take note, it's linear. When we do the first difference, we could know right away that it's linear because it will be constant. All right. If the function of h is linear, what is the function of the value of h of 15? Okay, h of 15. That means the x value here, we could put the x value here as 15. Right. What would be what is the value of the function of h of 15? That's the question. What is the value here? Here. All right. You have your choices. So let's do this. What can we do first? All right. We'll try to get the slope between these 2 points right here. Okay. Let's do this. Slope y2 minus y1. That's the rate of change. Let's do that. Okay. This will be the y2. This will be the y1. This will be the x1. And this will be the x of 2. So 17 minus 23, -4 minus a -8. 17 minus 23, that's -6. And 4 plus 8, that is equals to 4. So reducing, that will be -3/2. Okay. How about this point right here? We have to check if that is really a linear function. All right, let's check. So this will be my y2 now, and this will be my y1 now, and this will be the y2, and this will be the x1. All right. Okay. Y2 minus y1 over x of 2 minus x of 1. So I will have 5 minus 17 over 4 minus a -4. So that would be -12 over 8. Reducing, that's -3/2. That means the slope is constant. Right? The slope is constant. Then this function is a linear function. Okay. the next step that we're going to do, we could get the relationship from here, right? So that would be the difference 4 to 15. That's 11 difference. All right. So let's do another slope by using these two to get the value in h of 15. All right. So in other words, we could use this slope, still the formula. I have to keep on repeating this for you to understand the relationship. All right. We know that our value of slope is negative 3 over 2. So we have to substitute that. So y sub 2, we don't know. That's the one we're looking for when h is h of 15. Okay? Minus y1, which is 5. This minus that. And x sub 2 is 15 minus x sub 1, which is 4. Okay, let's do this. I'll use this space right here. So negative 3 over 2, y sub 2 minus 5, 15 minus 4, that's 11. Okay, I will cross multiply or multiply 11 on both sides, so that will become 11 times negative 3 over 2, y sub 2 minus 5. That would be 11 times negative 3, that's negative 33 over 2, y sub 2 minus 5. Transpose 5 to the left. So that would be negative 33 plus 5 is equals to y sub 2. We're almost there. Since we have a fraction of 2, we change 5 into a fraction. So least common denominator is 2, negative 33 plus 10. 2 times 5, that's 10. Negative 33 minus 10, that's negative 23 over 2, that is y sub 2. This is the value of when our input is h of 15. So that means this is negative 23 over 2. Okay. I hope this is clear, because there are several questions that will be asked in the pre-calculus exam, that you are given table and then you are asked to complete the table, or you are asked to find the missing value in the table. So these are the several ways how to answer those questions. Let's have another table here. The table gives values of the function g for selected values of x. So what do you have in your table? X is 0, 2, 4. And output value, g of x, is negative 5, negative 1, and 0. Okay. I then write down the question. If the function of g is quadratic, so this is a quadratic function, what is the value of g of 8? Okay, value of g of 8. All right. So let's find and solve those values. It says 8. So that means since the interval here is by 2, that means we could add another column to the table here. This would be 6, and this would be 8 as we move on to 8. Okay, so what we need is we have to complete the table and then find the G of 8. Okay, so what we're gonna do is we try to get the difference and see how it is decreasing. So let's say here -1 minus -5, that would be equals to 4. And I have to do it here so that it will be clear. 0. So I have a positive 4. 0 minus a -1, I have a positive 1. So we don't know what is when it's 6 and what is when it's 8. But what have we observed? If I get the second difference, 1 minus 4, that's -3. We could tell that from here that the rate of change is decreasing. By look at decreasing by 3 for every 2 x values, because our interval is by 2. All right. So in other words, if we try to look for this value right here, okay, I forgot to write down the choices. Sorry for that. We have a -5. We have 5. In C, we have -7. And D, we have 7. All right. So if we try to look at this, what do you think this difference would be when the value of we have 6? So let's say what would be this value right here to get this difference, right? So we'll make as -3 as our preference of the difference. So let's say 1, because we have -1, then we have a 0. So we can have we can do it here. Let's say from -1, then you have 0, -1, -2, right? The difference 1, 2, 3 going down, decreasing by -3. So count down 1, 2, 3, decrease by -3. So you could say that this is -2, right? And go down again from -2, you have a -3, then -4, -5. By just doing that, okay? By just doing that, decrease by -3, you will know that this is -7. Because 0 to -2, -2 plus 0, that is -2. The difference. -2 minus 0, that's -2. Then negative 7 minus negative 2, that would be a negative 5. And what's the difference from here? That is negative 3. Negative 5 minus 2, that's negative 3. By just looking at the first 2 points, or you can do 1, 2, 3 points, then you can get the rate of change, how it is decreased on the second difference, because we want to know the constant value of the rate of change, and our rate of change here is negative 3. And that is how when g of h is equals to negative 7. So you have the answer there. All right. Let's have this question. The function p is given by p of x equals g times the quantity of x plus 1 minus g of x, where g of x is a quadratic function. Okay? If p of x is equals to 2, which of the following statements must be true? If you try to look at these statements right here, because p is positive and constant, all of them are saying positive and constant, positive and constant. Okay, what we're gonna think, what we're gonna do, which one is true and which one is not true. The graph of g has always a positive slope. This is true. This is correct. Always a positive because p is positive. So g must be positive. Because p is positive and constant, the graph is concave up. That's a big question. Because, from the definition of concavity, we are trying to figure out when it's up or down, when it's up, what is increasing there. We are talking about increasing. Okay? We're not talking about being constant, but we're talking about increasing. All right, so this is not. When p is positive and constant, g is increasing. See the difference here? It is stated that the g is increasing. All right, this is correct. That means our choices is 1 and 3. So we could say, because here p of x times the quantity of g minus x, minus g of x over x plus 1 minus x. This is the average rate of change. Of g of x. All right. So you were able to review some of the solutions and problems with respect or in relation to rate of change in linear and quadratic function. Okay, so I can say this: if I can do it, so can you. So don't forget to hit the like and subscribe button. See you in my next video.